Welcome to The Explainer. Today we're taking a pretty incredible journey. Our mission? To completely demystify the absolute magic behind how our personal devices actually connect to the entire globe. I'm super excited to guide you through this, so you know what, let's just jump right in.
Seriously, take a second and really think about this. How did this very explainer actually reach your screen right now? You clicked a button and boom, seemingly out of thin air, data traveled across the world to show up on your display. I mean, it feels like magic, right? But it's actually a highly structured, brilliantly engineered system built on a foundational dynamic that we're going to completely break down today.
To really get this, we're going on a sort of zoom-out journey today. We're going to start up close by meeting the network hosts. From there, we'll be connecting the dots, mapping the network, scaling from LANs to WANs, and finally, exploring the whole global internetwork.
All right, Section 1. Meet the network hosts. Who is talking to whom?
So before we can understand the whole globe, we need to figure out exactly who is doing the talking, starting with the devices sitting right in front of us. In the networking world, we generally have two main actors in any conversation: clients and servers. You, sitting right there on your laptop or your smartphone, well, you're the client. You send a request, like, say, trying to watch this explainer. The server? That's the heavy-duty computer on the other end running specialized software whose absolute sole purpose is to provide that exact information right back to you.
Now, these devices usually interact in one of two distinct ways. On one hand, you've got the classic client-server model. It's centralized, highly scalable, the whole shebang. But then you have a simple peer-to-peer network. In a peer-to-peer setup, a single device acts as both the client and the server. It's incredibly easy and honestly super cheap to set up if you just want to, share a printer between a couple of computers in a room. But a quick heads up, as your network grows, this peer-to-peer setup completely lacks centralized administration, security, and scalability. It just can't keep up.
So here's the crucial takeaway. Whether you're a client requesting a file or the massive server providing it, in the language of networking, you're known as a host or an end device. Basically, if a message originates from you or if it's meant to be received by you at the very end of its journey, you, my friend, are an end device.
Moving right along to Section 2, connecting the dots, the invisible highways of data.
Okay, so we know who is talking. Now let's talk about the invisible highways that actually make that conversation happen across the planet. Between your client and the server lies this incredibly complex maze managed by intermediary network devices. Think of these guys as the traffic cops of the internetwork. They don't just passively interconnect end devices, they actively manage the flow of data. If an electrical signal is getting a bit weak over a long distance, they regenerate and retransmit it. They hold on to these complex maps of pathways so your data doesn't get lost. And if there's a communication failure, they immediately notify other devices to reroute the traffic. We're talking about your switches, your routers, your firewalls. They are the ones doing all this heavy lifting right behind the scenes.
But hold on. How does the data actually physically move between all these routers and switches? Well, it relies on three main types of physical media to push all those ones and zeros. First up, copper. This is your traditional metal wiring that sends data using electrical impulses. Next, we've got fiber optic cables. These use incredibly thin strands of glass or plastic to shoot literal pulses of light at just blistering speeds. I mean, it's actually light. And finally, wireless, which brilliantly modulates specific frequencies of invisible electromagnetic waves right through the air.
To ground these abstract concepts in the real world, just think about the hardware you interact with every day. You've definitely seen those twisted copper Ethernet cables, probably plugged right into your office wall. The fiber optic cables are a bit more delicate. They're usually hidden away in server racks or underground conduits, literally transmitting light. And of course, you have the very familiar antennas of your wireless routers at home. These are the literal physical threads holding our entire digital world together.
Which brings us to Section 3. Mapping the network. Blueprints versus postal maps.
So with all these copper cables, fiber optics, switches, and routers, things get messy incredibly quickly. To make sense of it all, IT professionals use two distinct types of diagrams or topologies. A physical topology diagram is, well, it's exactly what it sounds like. It shows the literal physical location of the intermediary devices and the cable installations. It's where things actually exist in a room. A logical topology diagram, on the other hand, completely ignores the physical room. Instead, it focuses purely on how the devices are virtually connected, illustrating the IP addressing scheme, the specific ports, and how the network is logically grouped together.
When you look at these two concepts side by side, the contrast is pretty amazing. Over here on the left is your physical topology. You can literally see the server room, room 2158, the specific racks, the exact shelves where the equipment sits. It is an architectural blueprint. Now look at the right. This is the exact same network, but represented logically. The physical rooms, completely gone. Instead, we see clean, organized IP addresses and subnets. It's essentially a virtual postal map. It creates a real aha moment when you realize you absolutely need both diagrams to truly understand and troubleshoot any network's design.
All right, let's keep zooming out. Section 4, from LANs to WANs, scaling up geographically.
As our networks scale up, they're categorized mostly by their geographic footprint and who actually manages them. First, you have a local area network, or LAN. This connects end devices in a limited area, like your house, a school, or maybe a single office building. Because it's local, it's usually administered by a single organization, and you get incredibly high-speed bandwidth between your internal devices. But what if you need to connect your branch office in New York to your main office all the way in London? That's when you need a wide area network, or WAN. WANs span massive geographic distances, interconnecting those smaller LANs. They're typically run by massive telecommunications service providers, and historically, they operate at slightly slower speeds than your blazing fast internal LAN.
To really grasp this leap in complexity, picture a self-contained LAN on the left, just a few computers, maybe an IP phone, all feeding into a single central switch, nice and contained. But then, on the right, you've got two distinct LAN branches separated by a huge distance. To get them to actually talk to each other, we have to bridge them together using a WAN link, which is represented by that red lightning bolt line between the two routers. And get this, that single red line could represent hundreds or even thousands of miles of infrastructure stretching entirely across a continent.
And that brings us to our final section, Section 5, the global internet work, the World Wide Web of networks. We've zoomed out from a single PC, to an office room, to a connected branch across the country. Now, let's look at the ultimate scale, the entire globe. As we organize networks on this massive level, we essentially build digital boundaries. The innermost boundary of privacy is the intranet. Think of this as the secure digital walls of a single company. It's a totally private collection of LANs and WANs meant to be accessible exclusively to that organization's actual members or authorized employees. It's a completely closed-off ecosystem.
But what happens if that company suddenly needs to share inventory data with a trusted supplier or a collaborating business partner? That is exactly where we use an extranet. The key takeaway here is that an extranet acts as a secure, heavily monitored middle layer. It punches a highly controlled, secure little hole right through those digital walls to grant limited access to specific outside individuals without handing them the keys to the entire private intranet.
And then, outside of all those private walls lies the public internet. You know, the internet isn't just some single magical cloud floating up there. It is quite literally a worldwide collection of all these interconnected LANs and WANs. It's a network of networks. And here's the wild part. No single entity, no individual or government actually owns the internet. Instead, it relies on global cooperative groups like the IETF and ICANN. They maintain its structure, addressing rules, and standards, just so that everyone's devices can actually understand each other, regardless of where they happen to be in the world.
Ultimately, all of these networks nest perfectly within each other. At the very core, you've got the intranet, strictly for the company. Wrapping around that is the extranet, allowing in your trusted suppliers and collaborators. And encompassing the whole thing is the vast, open public internet, connecting the rest of the world together. That nested structure, that is the global internet network in a nutshell.
As we wrap up the explainer today, I really want to leave you with a thought. Consider this. The next time you send a simple, casual text message from your phone, take a second and think about what's actually happening beneath the surface. How many copper wires, intermediary switches, routers, and literal miles of deep-sea fiber optics did your data just sprint across? How many invisible logical boundaries did it seamlessly navigate in less than a second? The convenience of our modern world, well, it isn't magic at all. It's a brilliantly designed, globally spanning internetwork. And now, you have the blueprint for exactly how it operates. Thanks for hanging out with us for this explainer, and definitely stay curious.